Okay, number 1 on the study guide for test 12, Bobby and Garnetta thought of 4 consecutive odd integers. So as soon as we start seeing consecutive integers of any sort, in this case specifically odd integers, we want to consider the pattern that occurs in those types of integers. So we think of odd numbers like 1, 3, 5, 7, and so on. Look at the pattern of how we get from number to number. It's a +2 pattern. That tells me that algebraically, if I let n represent some odd integer out there, the next odd integer is going to be 2 bigger than that, and then the next one's going to be 2 bigger than that, next one's going to be 2 bigger than that. So we just keep adding 2. So n plus 2, n plus 2 plus 2, n plus 4 plus 2, and so on. We need 4 of them, so you can see here I've listed 4. We see such that means some equation wording is about to happen. It says 3 times the sum. Remember, when we multiply a number times the sum, we have to put the sum in parentheses. It says the sum of the first and second, and is where the plus sign goes. We're adding the first to the second. This is the first, this is the second. So the first n added to the second n plus 2. And we put the entire sum in parentheses because 3 times the entire sum. The word was is equals. Anytime we see greater than or less than, we ignore. So 16 greater than, we don't care about yet. And then it says the sum of, which means addition, the third and fourth. So the third is this one, the fourth is this one, and we're supposed to add those together. Period means the equation's over, so now we deal with the greater than. 16 greater than happens after was, so at the far right-hand side we're going to put plus 16. If we said less than, we would have put minus 16. So at this point I need to simplify as much as possible. N plus 2 is 2n plus 2. If I distribute the 3 through, 3 times 2n is 6n. 3 times plus 2 is plus 6. On the right-hand side, n plus n is 2n, and 4 plus 6 plus 16 is going to be 26. So 6n plus 6 equals 2n plus 26. We'll move the 2n to the left-hand side, move the 6 to the right-hand side. In both cases, things that move change sign. 2n became negative, 6 became negative. These signs are opposite, so I subtract. These signs are opposite, so I subtract. In each case, the bigger number is positive, so we get positive results. Divide both sides by the coefficient, leaving with n equals 5. The fact that 5 is an odd integer gives me hope that everything I did was correct. At this point, that is only the first integer, so this is 5. We're supposed to list all 4 of them. So if we add 2, we get 7, add 2 again, we get 9, add 2 again, we get 11, to get our final answer of 5, 7, 9, 11. And I do expect all 4 numbers to be getting full credit on that. Number 2, Emilio Nesti had 480 grams of Freon in a container. What was the weight of the carbon in the container, given that the formula for Freon is this? So Freon is this formula. F is not Freon. F is actually fluorine, Cl chlorine, C carbon. So if I look at the ingredients of Freon, we have carbon, chlorine, fluorine, and then we have actual Freon, which is CCl2F2. We make a molecular weight column. Every carbon weighs 12, and we have 1 of them. Every chlorine weighs 35, and we have 2 of them. Every fluorine weighs 19, and we have 2 of them. So 2 times 19, 2 times 35, 1 times 12. 12 and 38 is 50, plus 70 is 120. So every molecule of Freon weighs 120 moles. And we want actual numbers over here, and we know that the Freon, 480 grams of Freon, Freon being this guy here. Alright, so 480 grams of Freon in a container. How much is carbon? Again, carbon, chlorine, fluorine. So carbon is this one. Get rid of chlorine and fluorine. And that gives me that 12 over 120 equals x over 480. I can reduce, so 10x equals 480 if I cross multiply. Divide both sides by 10, x equals 48 grams of carbon. Expect to be a chemical formula. I'll give you the molecular weights of each ingredient. It's up to you to understand what the formula means. There's two of these to get the correct molecular weights. I typically give you this number and ask you to find one of these. Number 3, the trip was only 150 miles, so Bob and Rita rode 30 miles per hour for a mile. Then they doubled their speed for the last part of the trip, so the total time was 4 hours. How far did they drive before they increased their speed? So they're here, and they drive part of the way. They decide they aren't getting there fast enough, so they speed up and go the rest of the way. So distance going slow, distance going fast. Let's go with those categories. And we know the total trip was 150 miles. So I know from beginning to end is 150 miles, which tells me the slow speed distance plus the fast speed distance should equal the total distance. And again, anytime you get these problems of uniform motion, that's priority 1. How do the distances relate? In this case, the two distances add up to 150. Next step is to make a rate time distance chart. We know they rode at 30 miles per hour for a while. That's the slow speed. And then they doubled their speed. Okay, their speed was 30. If we double that, we get 60. Okay, so they could have also said, then they decided to start driving 60, but in this case, they decided to double their speed. So it's up to us to establish that doubling 30 is 60. The total time for the journey. Some of you guys are still doing this wrong. I've said it 6,000 times now, so I don't know how else to say it. If you get the total time or a round trip time, if you're given a total time in anything, one of the times is t, the other is the total time minus t. That's how you set it up. That's the only way to do it. There's no other way other than just that right there. The slow time was not 4, the fast time was not 4. The slow time was unknown, the fast time was unknown. They add up to 4. T plus 4 minus t equals 4. So that's the only way to do it. That's it. Okay. So I could have put t here and 4 minus t there, but it's still the same thing. So in this case, 30 times t is 30t. 60 times 4 minus t is 240 minus 60t. And at this point, the slow distance is 30t. The fast distance 240 minus 60t. And according to my equation over here, they add up to 150. So 30t plus 240 minus 60t equals 150. So to solve, I simply have to move the 240 over here. 30 minus 60 is negative 30t. 150 minus 240 is negative 90. Subtract because the signs are different. Negative because 240 is bigger. Divide both sides by negative 30, we get t is equal to 3 hours. Okay, now the question that we have to answer here, because again, every time we do these problems, what we get there is not necessarily the answer to the question. The question is, how far do they drive before they increase their speed? So what you have to ask yourself is, what does that represent? Okay, how far is distance? So they're asking me for distance. What I found was time. Specifically, I found the slow time. Okay, so that does not answer the question they're asking me. How far do they drive before they increase their speed? They increase their speed here, so before they increase their speed is right there. So d sub s is what we're looking for, and that's 30 times t. So if I do 30 times 3, I get 90 miles. If it had asked how far do they drive after they increase their speed, the answer would have been here, we would have done 3 times 60 is 180, subtract, we would have gotten 60 miles. For how long did they drive slowly? 3 hours. For how long did they drive faster? 1 hour. Again, once you get an answer here, use the chart to interpret what that answer means, and then see if that answers the question. If it does, fine. If it doesn't, figure out which one they're asking for and do what you need to find that answer. Number 4, use trigonometry to find x and m. And you can see here that x is this side, m is that side. We got a 37-degree angle given to us. So if I use that acute angle, x is the opposite side of that angle. The right angle's here, 20 is opposite that, which makes that the hypotenuse, which makes m the adjacent side. Using trigonometry and the acronym SOHCAHTOA, I can see that I know the hypotenuse and I want to know the opposite. So based on wanting to know this and knowing this, sine is useful. Also, I can see I want to know the adjacent side and I know the hypotenuse. So the fact that I want to know this and I do know this tells me cosine is useful. Okay? The fact that I don't know either the opposite or the adjacent makes tangent useless. So I'm going to throw that one out. So just working with sine and cosine will get the job done here. And if I use SOH, S-O-H, that's sine of the angle measure we're working with over 1 equals the opposite measure x over the hypotenuse 20. CAH means cosine of the angle measure we're working with over 1 equals the adjacent measure m over the hypotenuse 20. So what we're creating out of these is just proportions. The over 1 is understood just to create a nice looking proportion. Cross multiply is happening. And I don't know what the sine or cosine of 37 is, but my calculator does. I'm going to start by making sure I'm in degree mode. So if I hit mode and I verify that degrees is picked, if it isn't, I would just bring my blinking cursor on top of degree, hit enter, make sure it's picked. Then you hit second mode to get out of there. The right mode says quit. And all I have to do to find out the sine of 37 is ask my calculator, hey calculator, what's sine of 37 equal? And it tells me it's 0.601815023. And the calculator also knows the cosine of 37 is nice enough to tell us 0.798635551. So those numbers simply go in here. And we want 4 decimal places. So 0.6018 for this one. And 0.7986 for this one. So now if I cross multiply, 1x equals 0.6018 times 20, which is 12.04. We want 4 decimal places here, and we want to round finals to 2 decimal places. So 12.04 is that one. And if I try the other one, across multiplying, 1 times m equals 0.7986 times 20. Comes out to 15.97. Alright, so, and that's all they're asking me for. They didn't ask me for the third angle. If they did, subtracting 180 minus 90 minus 37 would give us the third angle, but they don't ask for that, so we'll just move on. Number 5, same deal, use trigonometry, this time to find A. So we want to find this angle down here in the bottom. And again, if I focus on my acute angle that I'm working with, and I identify the opposite side, which is 4, the hypotenuse is opposite the right angle, which makes 3 the adjacent side. We can see very clearly here that the opposite side and the adjacent side are the ones we know. And again, if I focus on SOHCAHTOA, the fact that I know the opposite and I know the adjacent means that tangent's going to be helpful here, cosine and sine won't. And again, using good trigonometry writing here, t is tangent of an angle that we're working with, which is A in this case, over 1 equals 4/3. Again, if we write our trigonometry expression out like that. Now in this situation, we don't know what the angle is. So I can't type in tangent of some angle because I don't know what the angle is. So in this case, since I'm looking for the angle, I'm going to use the inverse tangent mode on my calculator. So, this says tangent, so I did inverse tangent. If it said sine, I do inverse sine. If it said cosine, inverse cosine. So depending on what sides I give you, sine, cosine, or tangent, you have to pick which one's the right one to use. And then again, you're not going to know the angle, so you're going to want to use the inverse trig function of that, of this number. So I'm just going to hit second tan, 4/3, in parentheses. So notice 4/3 encased in parentheses. I have inverse tangent of that whole thing. And I get 53.13 degrees. Alright, and that's all they're asking for, so that's it. The end. Number 6, find m. Okay, anytime it says to find a letter and you got fractions in your problem or parentheses, you want to deal with those things first. I'm going to deal with the fraction issue since that's all I've got. The common denominator is md. So we multiply md times each object. So md times k over m makes kd. md times minus c makes minus cmd. And md times p over d makes pm. Okay. Simply divide first, then multiply the results. So the m's cancel, kd is left, nothing cancels, cmd, d's cancel, pm left. Once you get down to just a bunch of terms that aren't fractions, no parentheses, now it says find m. M is located in this term and this term. We want those terms together. Quickest way to make that happen is move to CMD over to the right. So KD stays on the left. PM stays on the right. Both of those stay positive because they didn't move. CMD is moving across, becomes positive. Common factor of M comes out. So M belongs to both objects. Taking M out, P is left over, CD is left over. And then the last step, we're going to get KD on top and P plus CD on the bottom. Notice there's no M over here. Now some of you are still dividing by the M also. The rule says with algebra, if we have something times what we care about equals something else, we divide by the something that's being multiplied by it only. So that cancels that, leaving M all by itself on the left-hand side. Everything on the other side is just going to be everything that isn't M. So be careful. Some of you are still trying to put the M over here also. M all by itself equals everything that isn't M is what you're looking for a final answer. Number 7, same type of problem. Once again, we have fractions. This time the common denominator is CPM. So again, if I multiply through like this, CPM times this, the C's cancel. I get 3APM. CPM times this, the P's cancel, leave me with minus CDM. And this times this, the M's cancel, leave me with CKP. Went ahead and went alphabetical order. Actually, I didn't even know the 3APM. But anyway, went alphabetical order on the other two terms. It doesn't matter about order. But if you feel like it, you can go alphabetical. It says find C. This term and this term both have C in it. So I'm going to move the CDM over to the right-hand side. So 3AMP, I'm going to go ahead and alphabetize that one. 3AMP is left on the left-hand side, equals. CKP is staying on the right-hand side. So both these terms stayed where they were. They stayed positive. CDM is moving across, so plus CDM. Sign changes. We're trying to find C. C belongs to both these guys, so take a C out. KP plus DM is left over. And again, final step, we're going to divide by that stuff. So C all by itself on the right-hand side equals the left-hand side over the stuff we're dividing by. Number 8, they have a statement here that says ABCD is a parallelogram, which immediately opens up all the parallelogram properties. And the property we're going to work with here involves the diagonals of a parallelogram. And that property simply states that the diagonals cut each other in half, which means that this piece here is the same size as this piece here, which means that y minus 2x has to equal 6. I can't solve that because there's too many letters, so I move on to the other fact. This one also got cut in half, which means this piece, 2x plus y, has to be the same as this piece, 10. The way it's written, that's xy order, that's yx order. If I rearrange, let's make this top one, I'm going to rearrange to negative 2x plus y equals 6. Same expression, better order. 2x minus 2x cancels, y plus y is 2y, 10 plus 6 is 16. Divide both sides by 2 to get y equals 8. And once I know y equals 8, I know that 2x plus y is equal to 10. You can see I replaced y with the number 8. I did one with that equation there. And did my substitution of y equals 8 in for y. Move the 8 over, so 2x equals 2. Divide, we get x equals 1. Just like that, find x and y. There they are, 1 and 8. Number 9, solve by factoring. To solve by factoring, first thing we want to do with polynomial function, power is involved. We want to get everything equal to 0. I like my highest power term positive. Right now it's negative, so I'm going to move everything to the left to make this happen. So x cubed becomes positive when I move it to the left. 3x squared becomes negative when I move it to the left. 2x is already on the left, it's positive, so I put a plus sign in front of it. It's like that. So it's job 1 is done. Everything's on the left-hand side now. Job 2. We only know how to factor quadratic stuff, so if you have anything higher than the second power, probably have a common factor, x in this one, x in this one, x in this one. If I take x out, I'm left with x squared minus 3x plus 2. And then if we look at our quadratic trinomial here, I'm looking at that as a factorable expression. I know that -1 and -2 make the proper product and the proper sum. So x minus 1, x minus 2 times the x that's already there is equal to 0. Once you get everything factored, so everything's linear now, x to the first minus 1, x to the first minus 2, we simply take each factor, this one, and this one, and this one, and set them all equal to 0. So we're not done here. Some of you are stopping here on homework. It says solve, and you're just giving me this factored form, which is great. It's just not finished. X equals 0, x minus 1 equals 0, x minus 2 equals 0. X equals 0, done. X minus 1 equals 0, that gives me x equals 1. X minus 2 equals 0, that gives me x equals 2. So x equals 0, 1, and 2 are the solutions to the problem. When it says solve, that's the type of answer you're looking for. You're not looking for the factored form. Factored form helps you get the numerical answer you're looking for, but it's not the end of the problem. Get me to here. Number 10, solve by factoring. Okay, so what I'm looking at here, this is the difference of squares, so recognizing structure as far as how to factor. When I see a difference of squares, it does equal 0. That's a very necessary thing. Since it already equals 0, it's ready to go right off the bat. Simply have to ask yourself what times itself makes each term. So 4p times 4p, that's located in the front, so I put the 4p's in the front. 7 times 7, that's located in the back, I put the 7's in the back. That's negative 49. It's 1 positive 7, 1 negative 7. So there's my factored form. 4p plus 7 times 4p minus 7 equals 0. To verify that it's the same thing, if I FOIL that, 16p squared minus 28p plus 28p cancels, minus 49. So you can see that they're exactly the same. In the same situation as the last problem, I got factored form equal to 0, so factor 1 equals 0, or factor 2 equals 0. So I'm going to do 4p plus 7 equals 0, or 4p minus 7 equals 0. Then I simply solve each of these individually. Move the 7 over. That gets me 4p is equal to negative 7. Divide by 4. We get p equals negative 7/4. This one here, move the 7 over, add 7. We're going to get 4p is equal to positive 7. Divide both sides by 4. That gives me p equals positive 7/4. So altogether, my answers are p equals plus or minus 7/4. Alright, so that's solving by factoring. Number 11, simplify. We are dividing the polynomials, so this one has to flip. My personal preference on these is I don't like cubic stuff in these things, I like squares. So if I see cubic stuff, I've got this common factor idea happening here. So this guy and this guy, as I'm doing my rearranging and making it into the multiplication problem, I'm going to take the common factor of x out for each of those. So for this one, taking x out, I'm also going to rearrange the order. Highest power, middle power, lowest power, so I'm going to go that order. So x squared is left over from the cube, x to the first, so 4x, and then 3 is only left over from that. So that's equivalent to this. That has the x out, this has the quadratic left. I'm going to put that over x squared minus x minus 2 times, this goes on top, x squared plus 3x minus 10. And then this goes in the bottom, again, common factor of x comes out, x squared plus 7x plus 12 is left over. Okay. Job 2, factor everything. Top, 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 bottom, bottom, bottom. You can just make one big fraction bar at this point if you wish. If you look at each piece individually, deal with this one first, this one second, this one third, this one fourth. So, x is already taken out, so that's fine. 3 times 1, 3 plus 1, so x plus 3, x plus 1. Negative 2 times 1, negative 2 plus 1, so x minus 2, x plus 1. Be careful that the signs are such that they multiply to make the negative number, they add also to make a negative number, the bigger number is negative here. The green one, negative 2 and positive 5, so x minus 2, x plus 5. Again, if I verify, negative 2 times 5 makes negative 10. 5 plus negative 2 makes positive 3. On the bottom, we got an x already. And I might put parentheses around it just to reinforce that that's an x, not a multiplication symbol. 3 times 4, 3 plus 4. So x plus 3, x plus 4. And again, if we do verification real quickly, 3 times 4 is 12, 3 plus 4 is 7, 1 times 3 is 3, 1 plus 4, 1 plus 3 is 4. All the stuff's right. At this point, we're looking for common factors. They have to be exactly the same to be common factors. This matches this, they cancel. 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 That doesn't match, that doesn't match. Nothing else matches. So my final answer is simply what's left over. I will make it on the test so it comes out to a nice pretty answer like that. I'm not going to make it where you have to multiply it all back together. So everything but one thing on top and bottom should cancel if you do it correctly. Number 12, simplify. Job 1, identify all the pieces of the numerator and denominator based on the main fraction bar. This is the main fraction bar. Numerator piece, denominator piece. Those being subtracted, those are being added. Both of these guys are fractions. That's the issue. We don't want fractions in the fraction. So looking at the two fractions, common denominator of x, so times x, times x, times x, times x. Each of the x's represents a numerator object being multiplied by an object. So 4x numerator object times x numerator object, those multiply to make 4x squared. Nothing cancels because there's no fractions. Here there is a fraction, numerator piece, denominator piece, that matches that, they cancel, so I get minus 3. Fraction, denominator piece, numerator piece, that cancels that, we're left with 5. And then here, these are just non-fractions, you just get 2x, that is a plus sign, so I put a plus, that's a minus sign, I put a minus. About the only way anybody's missing them right now is they put the wrong signs in here, and that's just carelessness in my book. So just be careful that you do that correctly, get the correct signs when you do that. Again, fractions cancel, non-fractions don't. Common denominator is what it is. 13, we just dealt with these problems recently where they threw this extra term here on the end. If I real quick did a factor tree for 90, in case we didn't know that, it's 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. All right, so looking at this, piece 1, 3 to the square root of 2/5 is 3 square root of 2 on top over the square root of 5 on the bottom. Leave myself some space. Second term is plus 7 square root of 5 over the square root of 2. Leave myself a little space here, and leave myself a little space here. And 2 times 3 times 3 times 5. I like numerical order when I'm listing a prime factored form there. So 2, 3, 3, 5 is the prime factor form of 90. And again, that 90 is being subtracted, that 7 is being added, that 3 is positive. So recreate the problem in this manner. The fractions become square root of top and square root of bottom. The square root here becomes a simplified square root by taking out the perfect squares there. So for the black one, the fix is going to be multiplication by the square root of 5 on top and bottom. For the red one, the fix is going to be multiplication by the square root of 2 on the top and bottom. For the blue one, the fix is going to be take the pair of 3's out of the 3. So each thing's fixed in its own manner. Each term is different. They're fixed however they're fixed. And once I fix them, they're going to be whatever they are. So this first one is going to become 3 times the square root of 10 on top, 5 on the bottom. 3 is not a radical. These are radicals, so they multiply underneath the radical. Square root times itself makes the number without the radical. The second term, 7 is not a square root, so it stays right where it's at. Square root of 5 and 2 inside the radical makes square root of 10 inside a radical. Square root of 2 times itself on the bottom makes 2, no radical left. For the blue term, minus 3 is 3, and then the square root of 2 times 5 is the square root of 10. I'm going to put that over 1 just to make it look like a fraction. At this point, every radical piece should be the same thing. Square root of 10, square root of 10, square root of 10. If they aren't, then the bigger numbers will do the same thing that happened here. So if this was, let's say, square root of 40, square root of 40, square root of 10, 40 is 2 times 2 times 10, so the pair of 2's comes out. So again, if this doesn't happen in these problems, whatever the bigger number is, do a factor tree, pull out your common factor like that. And what we're looking at here, square roots of 10 over 5, 2, and 1, common denominator of 10. So each one of these fractions doesn't have a 10 denominator, so this needs a 2, so times 2. This needs a 5, so times 5. This needs a 10, so times 10. Each case, what do you need to multiply to make what you're looking for? So what we end up with for the first term is 6 square root of 10. For the second term, we're going to get plus 35 square root of 10. And for the last term, we're going to get minus 30 times the square root of 10. Over 10, the over 10 is required. There's no equal sign in this problem, so there's no way to get rid of the fractions. It's going to remain a fraction all the way through the process. All we have to do to get the numerical value on top is add and subtract the stuff. 6 plus 35 is 41, minus 30 is 11. And that's the final answer for that. Number 14, solve. Let me just highlight really quickly where some of you are going to mess up if you're not careful. There's a minus sign in front of that second fraction. So if I split the fractions apart into separate pieces, so start off with this one here. That's 5x over 3 minus 2 over 3. There's no sign in front of the fraction influencing anything, so 5x stays positive, 2 stays negative. They're both over 3. The second fraction has a minus in front of it, so that minus is influencing the numerator. So minus 2x over 2, and then minus minus makes plus 4 over 2. Be careful that that minus minus makes a plus happens. Equals 10. Now what you might notice is 2 over 2 and 4 over 2 both reduce. If you want to reduce it, that's not wrong. You can do that. I'm going to leave it as is because it's just one extra step. It's not going to make the problem that much more difficult to deal with the 2's. Looking at the fractions that I have, 3, 3, 2, 2, the least common denominator is 6. And it's just a matter of multiplying this times this, times this, times this, times this, and times this. And each of the fraction multiplications divide first, then multiply the result times the top. So 6 divided by 3 is 2 times 5x is 10x. 6 divided by 3 is 2 times negative 2 is negative 4. 6 divided by 2 is 3 times negative 2x is negative 6x. 6 divided by 2 is 3 times positive 4 is positive 12. And 6 times 10 is 60. There's no fraction there, so no cancellation, just multiply what you got. And we get this nice non-fractional problem that's really easy to do. So what's left is to simplify. 10x minus 6x is 4x. Negative 4 plus 12 is positive 8. 4x plus 8 equals 60. We move the 8 over here, subtract. We're going to get 4x equals 52. We divide by 4, we get x equals 13. If you don't make that a plus, you're going to get minus 16, you're going to get 76, you're going to get 24 as an answer, which seems, well, 76 divided by 4, 19 is an answer. Seems like a reasonable answer, but again, it's wrong because that minus minus makes a plus, and you do have to get that right, so be careful of that. Number 15, add x over x minus 3 over x squared minus 9. As soon as I see an addition of fractions and I see a quadratic denominator, I'm looking for factoring possibilities. So the first fraction can't be made any prettier, so this is going to stay x over x minus 3 for right now. Leave some space here just in case I need to do something with it. Then I got minus 3 over, and then I'll look at x squared minus 9. That's a square minus a square, that's the difference of squares. X times x makes x squared, 3 times 3 makes 9, 1, 3 positive, 1, 3 negative make negative 9. Now, comparing denominators, I can see that this denominator has x minus 3, so does this. This denominator has an x plus 3, this doesn't, so it needs an x plus 3, so I got to put an x plus 3 on top also. At this point, they both have x plus 3 times x minus 3 denominators. They have common denominators, so subtraction is legal. I need to simplify as much as I possibly can. X times x is x squared. X times plus 3 is plus 3x. Minus 3 all over the common denominator. What would be left on top would be to add like terms. There aren't any. So that is the final answer there. So that's what we're looking for on that one, and should look similarly on the test. Again, look for factoring possibilities, and again, if you have a common factor already, that's already been dealt with. This has x plus 3, that didn't, so it needed an x plus 3 on top and bottom to be fixed. If you don't get me the least common denominator, you won't get full credit. Okay. If you just multiply this times this, that would be a common denominator. It makes a much uglier answer, much harder to do. So it would be harder for you to do, harder for me to grade, so it's not worth doing. Look to factor first on those.